So, in the absence of any question, I believe all of us understand. So today, I'm going to be starting with the formula for resistor in series and resistor in parallel. I did not come with a slide today. I came with so many questions and so many solutions. So I want you all to, as much as you can, write down what you can, because we'll be needing it. So I want to the formula for resistor when they are in series. I hope you can all see. Please, I want to know through the chat if you are following me, please. Then when resistors are in parallel, hope I've gotten this down. I'm sure that we have heard about this before. We know this already, but I hope I've all gotten it down. If you have, I'm going to write out the next formula we're going to be needing for the day. The next formula we're needing for today is RV is equal to IR. Can we remember? I hope we all know V is equal to IR very well. So if we know these formulas, then we're good to go. I'm going to share the first question with you guys now. So I hope you can all see this diagram. If you can, please get down the diagram, because we want to solve. This is a circuit diagram. It has 4 resistors. Anybody, what's the relationship between resistor 1 and, resistor 2 and 3? Are they arranged in series? Are they arranged in parallel? Resistor 2 and 3, anybody? I'm waiting up, guys. Resistor 2 and 3, are they arranged in parallel? Is anybody in class? I wish I were all in class. Resistor 2 and 3, are they arranged in series or parallel? 2 and 3, series, yes. They are arranged in series. Resistor 2 and 3 to resistor 4, are they arranged in series or parallel? We have agreed that resistor 2 and 3, they are arranged in series. Yes, correct. Then resistor 2 and 3 as a unit, series arrangement, to resistor 4. How are they arranged? Resistor 2 and 3 as a unit, we agree that they are a unit, right? So to resistor 4, how are they arranged? Is it still a series arrangement or is it a parallel arrangement? Yes, it's a parallel arrangement. Resistor 2 and 3 to resistor 4 is a parallel arrangement. So guys, let us start. If we want to solve this circuit diagram, we have to look at, okay, where is the easiest place I can start from? Then, from my little knowledge of electronics and physics, I would advise that when you want to start breaking down a circuit, start from the opposite side of the voltage. I don't know if you understand what I'm saying. If the voltage is by the right, start from the left. If the voltage is by the left, start from the right. Doing that, it will be easier for you to break down the circuit. So now, in this question, if you want to break down the circuit, the best thing to do is solve for resistor 2 and 3. What is their joint resistance? Everybody. Resistor 2 and 3. We know the formula for arrangement of resistors in series. Their joint resistance, let it be RA. For resistor 2 and 3, what is their joint resistance? For resistor 2 and 3, what is their joint resistance? Okay. Any other person? Okay. Okay. Good one, guys. We all agree it is 12. So how did you get our 12? We said 8 plus 3, 12. So we have agreed that this particular resistor now, 2 and 3 is now 12. Then it means that, okay, let me share a screen. Let me draw the diagram so that we can all know what we're saying. I really want us to understand because it can be tricky. This is what we're doing. Sorry for the diagram. We've gotten resistor 2 and 3. Please don't be annoyed about the diagram. I know you all understand. We have agreed that resistor 2 and 3 is this. So we said this is 12 ohms, if I'm correct, and this is also 12 ohms. I'm not with the diagram, so I don't know. But this is also 12 ohms. So let us agree that this is resistor RA. The joint resistance we got for 2 and 3 is resistor RA. So for RA and resistor 4, what? Okay, they are arranged in parallel. I hope we all know that RA is parallel to resistor 4. The joint resistor of resistor 2 and 3 is parallel to resistor 4. So for resistor 4 now, what is going to be their joint resistor? What is going to be their joint resistance? Let that be RB. So what's their joint resistance? I'm waiting, guys. What's their joint resistance? What formula are we going to use? I'm erasing the diagram. 12, though. RA is 12, R4 is 12. We're going to be using formula for resistors in parallel. Don't let us forget, resistor in parallel. 1 over RB. We said our answer is RB is equal to 1 over RA plus 1 over R4. So we're looking for 1 over RB. 1 over 12 plus 1 over 12. When we find the LCM, we have 12, 1 plus 1. So 1 over RB is equal to 1 over 6. 2 over 12 is equal to 1 over 6. Then RB, our resistor RB is 6 ohms. Do we all understand? If there is any question, can I know, please? Kindly let me know, guys. Any question, any question, any question?
No, ma.
Okay, so we agree that there is no question. It means we all understand. Kindly let me know from the chat if we understand or not. Okay, so after this, it means we have gotten we've gotten RARB. Let me share the diagram again so that we would know. Okay, then after this, it means we have solved for these three resistors. Then the last one, we are looking for the equivalent resistor. So let me see. Okay, I want to check what the resistor is actually. Okay, resistor R1 is 6, and our equivalent resistor here is 6. We've gotten 6. And we should not forget that our volt is 12 volts. So let us draw it again. You guys shouldn't be angry about my diagram. I'm sorry, guys. This is 6 ohms. This is 6 ohms. This is resistor RB, and this is resistor R1. So guys, what is going to be resistor R1 and resistor RB? The arrangement, are they arranged in series or parallel? Guys, resistor RB and resistor R1, are they arranged in series or parallel? I'm waiting up, guys. Resistor RB and resistor R1, are they arranged in series or parallel? Series or parallel? Okay, yes. Resistor RB and resistor R1 are arranged in series. Look at it. I know it can be confusing because it's just like a curve. But we should know that, okay, let us assume that this is the positive, this place I'm touching is the positive side. Let's assume that this is the positive of this is the negative of this, positive of this, negative of this. So this is a series arrangement. I can also draw this to mean 12 ohms, 12 volts, and just draw this way. It's the same thing. This diagram and this diagram are the same. So guys, if we have agreed that resistor R1 and resistor RB are arranged in series, what is going to be their equivalent resistance? The equivalent resistance for this is going to be what? I'm waiting up, guys. If they are arranged in series, the equivalent resistance is what? 12. Yes. You guys are making my day today. You're making me happy. Alhamdulillah. Well done, guys. Thumbs up to you guys. So now I've gotten our general resistance, our resistance to be 12. Please, what is going to be the current? Now that we know that resistance is 12, voltage is 12. R is 12 ohms. Voltage is 12 volts. What's going to be the current? I'm waiting for you guys to answer that question. What's going to be the current? 1 watt. 1 watt, 1 amp. Any other answer? Guys, we are still going to solve for the voltage of almost all of the resistor and the current of almost all of the, we are still going to solve for the voltage and the current of almost all of the resistors individually. So I would like if we can be fast about this. And we have at least 6 to 10 questions to solve today. This is the first one. Okay, yeah, one arm. Barakallahu fi, guys. Well done. Well done, everybody. So after getting this, we already have the voltage, we already have the current. So I want to share the picture with you again. So right now, we want to calculate So right now, I want to calculate the current. It means that from this place, from IT here, a current of 2 ampere is flowing through R1. R1 and R3, R1, R2, R3, R4. R1 is in parallel to R2, R3, and is in parallel to R4. So when resistors are in parallel, their current is what? Guys, when resistors are in parallel, what happens to their current? Guys, now, when resistors are in parallel, what happens to their current? When resistors are in current, when resistors are in parallel, their current is being shared. It means that for R1, the current there is the voltage, because it's in series, is in parallel to others. It means the same voltage cuts across them. So for R1, the current is 1 over V is equal to IR. Then I, which is the current, is equal to V over R. And our V is what? Guys, I'm waiting. Our V is 12. What else? Our R is what? So what's going to be the current? The current that flows through R1 is 0.5. And the one that is shared between I1 and I2 is also 0.5. So any question before we move on to the next question? No. 0.5. Any question before we move on to the next question? Any question, guys? Guys, question. I'm waiting. Okay. All right, I'm going to share the solution with you now. Let me see where it was written down. Just use your formula V is equal to IR. We should know that I'm coming, guys. Please let me. Okay, guys. Let me share the picture with you again so that I can explain. Let me see. Okay, guys. The current coming from here is 1 amp. It goes here. When it gets to this point, when it gets to point I1, are we all listening? When it gets to point I1 and I2, it divides itself. 0.5 comes here into 2, and 0.5 comes here, because by the time we add these resistors, when they are in series, they give us 12 ohms. It means equal amount of current goes from here to this place. I hope you understand. Equal amount of current goes from RA. Hope you can remember our diagram when we got RA to be 12 ohms and we have R4 to be 12 ohms. Equal amount of current goes from RA to R4. So the current in RA is 0.5 milli or 500 milliampere or 0.5 ampere, and the current in R4 too is 0.5 ampere or 500 milliampere. I hope you all understand. Any question before we move on to the next example? Please let us see the current that is coming from IT. It moves through this resistor because that is the only resistor is in contact with at the moment. When it gets to the point where we have I1 and I2, it splits. The same current splits, and it has I1, I2, 0.5 ohms, 0.5 ampere goes to, is being distributed between 8 ohms and 4 ohms, and the remaining 0.5 ampere goes to 12 ohms, that is R4. Any question, guys? Any question? Okay, in the absence of no question, we're going to moving on to the next example. This is pre-solved. No, this is. There is a very tough question I want us to get to today. So we have to be very fast. Okay, this is simple. This is simple. So in 1 minute, I want my answer. I want the answer for, okay, if you have a question, please ask, let me know. Please ask, let me know. Let me know if you have a question. Someone raised a hand now, so I would want to know if you have a question. Can you let me know? Okay, now we have R1, R2, R3, R4, R5. They are all arranged in what, guys? Is this a series arrangement or a parallel arrangement? I want 3 answers from you. Tell me the arrangement it is, give me the equivalent resistance, and give me the current. I want to know what the current of this circuit is, the equivalent resistance, and the current. And the current, guys. Okay, guys, I'm waiting. Somebody got 70 ohms. I disagree with that. Though I agree with your current, but I disagree with your equivalent resistance. So guys, I'm waiting. We must solve that question together. Oh. If we don't, it's going to be the first thing we are going to be solving next week because we must. Okay, no answer. Yes, the equivalent resistor is the equivalent resistance is 90. And the current is 0.1 ohms. Everybody is correct. Everybody is correct. Yes, guys. Well done. Well done. Well done. Well done so much, guys. You have all done well and you're doing well. Okay. So the next one. So this is the next question we're solving. Resistor R1, R2, R3. Our questions, we're supposed to look for voltage 1, resistor 1. We're supposed to look for current 1, voltage 1, current 2, voltage 3. But before we start that, we need to look for the current 1. So what's the equivalent resistance of resistor 2 and 3? Resistor 2 and 3, what kind of arrangement do they agree with? Is resistor 2 and 3 arranged in series or in parallel? Resistor 2 and 3, are they arranged in series or in parallel? So if resistor 2 and 3 are arranged in parallel, what is their equivalent resistance? They are arranged in parallel. Resistor 2 and 3, they are arranged in parallel. So what's their equivalent resistance? What's the equivalent resistance between the two of them? What's the equivalent resistance? The equivalent resistance first. I want to know what the equivalent resistance is. What's the equivalent resistance? 0.1. The equivalent resistance is 4.1. So what is the current? The current. No, rather. I'm sorry, guys. Sorry, just a minute. We got the equivalent resistance for R2 and R3. It means R2 and R3 is arranged in parallel to R1, in series rather to R1. So what's going to be the equivalent resistance between R1 when it's 1.0 ohms and RA, which is 4.1 ohms? So guys, let me use the whiteboard so that I can communicate better. We agree that 1 over RA is equal to 1 over 6 plus 1 over 13. So we got RA here to be 4.1. So our equivalent resistance is R1 plus RA. We have 1 plus 4.1, and that is 5.1 ohms. So it means the general resistance here is 5.1. It means the general resistance here is 5.1. Yes, 5.1 ohms. So what is the current? If the if the equivalent resistance is 5.1 ohms, what is I1? Let me share the picture again. So what is I1? What is I1? Don't let us forget our formula. V is equal to IR. Our V is 12. We're looking for our I, and our R is 5.1. So our I is what? 12 divided by 5.1. Okay. Yes. We have our I to be 2.4 ampere. 2.4 amps. 2.4 amps. Nice one, guys. Very nice. Very, very nice. Okay, so I've gotten the current to be, we have gotten I1 to be 2.4 amps. So what's going to be V1? What's going to be V1? What's going to be voltage V1? Voltage V1 is I1 times R1. Voltage V1 is I1 times R1. 2.4 times 1 ohm. So you have 2.4 volts. Are we following, guys? Yes, 2.4 volts. Nice one. Then what is going to be our current I2? What's going to be the current I2? Current I2, guys. Current I2. Current I2. Current I2 is but really before we can get current I2, it will be better if we can get voltage V3. And V3 is just V is equal to V1 plus V3 rather. That was a mistake on my part, I'm sorry. Yes. The same voltage will flow through R2 and V3. The same voltage will flow through R2 and R3. So it means V2 is equal to V3. From when we said that when resistors are in parallel, their voltages are equal and their currents are different. So V1 plus V3 is equal to V. So what is V3? V1 plus V3 is equal to V. What is V? I hope we're all understanding. I can just see very few people attempting to solve the question. Please, when you are lost, please just let me know. Guys, we are looking for voltage V3. V3, what is voltage V3? No answers yet. Voltage V3. No, not 24. Voltage V3 is V1 plus V3 is equal to V. So V3 is equal to V minus V1. We got our V1 to be 2.4. That's 12 minus 2.4. What answer would you get? Yes, you are raising your hands. Please, can you just send a message about what you want? Just tell me via chat what the problem is so that I would know. Okay, where don't you understand from? Or what exactly don't you understand so that I would know? Yes. The voltage V3 is 9.6 volts. Yes. Sorry, please, where don't you understand from? But I'm going to explain all over again this particular diagram. In this diagram, R2 and R3 are in parallel. So when we solve for the solution of R2 and R3, we got 4.1 ohms. I'm explaining again, please. For R2 and R3, we use the formula 1 over R is equal to 1 over R2 plus 1 over R3. That is 1 over R is equal to 1 over 6 plus 1 over 13. After we did that, we now got RA to be equal to 4.1 ohm. So we wanted to get the equivalent resistance for all of the resistors in this circuit. So it means that if we have gotten R2 and R3, their combination to be 4.1 ohms, the combination of R2 and R3 are in series to R1. So it means their series combination is 1 plus 4.1. So the equivalent resistance for this circuit is 5.1 ohms. Then we use the formula for our basic circuit. V is equal to IR. Our V from the diagram is 12 volts. Our R from our own calculation is 5.1 ohms. So we made I the subject of formula, that is 12 over 5.1. So we now got I to be equal to 2.5 amps. To this point, who does not understand? To this point, who does not understand? In the absence of a person that does not understand, let us move on. Then after we have gotten the current to be 2.4 to be 2.4 amps. We wanted to get the volts V1, the voltage in resistor 1. Using our normal formula again, V is equal to IR. The current in resistor 1 is 2.4. The resistance of resistor 1 is 1.0. So we just say V is equal to IR. 1 times 2.4. So the V1 for resistor 1 is 2.4 volts. So now we want to look for the current I2 of resistor 2. Wanted to look for current I2. So we now said to get current I2, we have to look for V3. Remember that for resistors in parallel, their voltage is equal. It means the voltage in resistor R2 is the same voltage in resistor R3. So with this, it means that our resistor V3 is V, the general volts. Maybe they are sharing it. V1 has taken its own part of it and is giving the remaining one to V2 and V3. And V2 and V3, because they are in parallel already, they don't share. They use the same amount of volts. I hope we're all understanding. Because V2 and V3, they are in parallel. They use the same amount of voltage. So we said to get V3, it means V minus V1. V is 12. 12 minus 2.4. Then we got V3 to be 9.6. Don't forget that for resistors in parallel, their currents are different, but their voltage is the same. So to get I2, current 2, we'll say V is equal to IR. V2 is 9.6. R2 is 6.0. Look for I2, guys. V2 is 9.6 because V2 and V3 are equal. I2 is what we're looking for. Then R2 is 6.0. Oh, I don't know. Is there anybody that cannot hear me? Oh, sorry about that. If you cannot hear me, or if you can hear me, kindly wave your hand so that I would know. If you can hear me, guys, wave your hand so that we know. Okay. An appreciable number of people can hear me. Sorry about that. Try and check the audio connection of your phone. See if you have joined via audio. Sorry. Yes, 1.6 amps. Okay, guys. All right. So, what is our I2? Any other person that have solved for I2? Any other person that have solved for I2? It's not 0.6. It is not 0.6. What you are doing is 9.6 divided by 6. What you are doing is 9.6 divided by 6. Okay, what you are doing is 9.6 divided by 6. All right, very well, guys. Very well. Very, very well. I hope you all understand to this point. If there is any question, kindly let me know. The next question we're going to be solving. I don't know if we would have enough time to finish this question today, but we're going to solve it as much as we can. Then I've solved the question. I'm going to send the solution if we don't have enough time to finish solving it. So now, this is a circuit. The only thing we want to look for in this circuit is we want to look for the equivalent resistance. It looks like it's a wow circuit. We're not using Kirchhoff, we're not using anything. We're using our series and parallel arrangements. We're doing it that way. So let us assume that the side where, oh, I'm sorry, guys. Let us assume that the side where we have A to B is the side that we have the voltage. It means we are starting our solution from the other side. We want to resolve resistor R10, R8, and R6. I'm just going to tell you the step-by-step solution to this. We'll get there. We just have to be calm and solve diligently, and we're going to get there. So resistor R8 and R10, what kind of arrangement do they possess? Guys, resistor R8 and R10, what kind of arrangement do they possess? Guys, it's almost 12. Let's be fast. R8 and R10 are arranged in what? Series. And they are in parallel to what? R8, R10 are arranged in series. And they are in parallel to R9. So what is the equivalent resistance of R8 and R10? They are arranged in series. What's their equivalent resistance? R8 and R10, what's the equivalent resistance? 12 ohms. 12 ohms. 10 plus 2 is 12 ohms. And they are in parallel to resistance R9, which is 6 ohms. So what is the equivalent resistance for the three of them? What is the equivalent resistance for the three of them? I'm waiting for you guys. What is the equivalent resistance for the three of them? I hope you can all see this. This is the solution to the first part. I hope you can all see this, guys. If you can't, or if you can, kindly let me know. This is the solution. Guys, can we see how we got our 4 ohms? Guys, can we see how we got our 4 ohms? If you can see this clearly, can you wave your hand? Let me see. I'm waiting for you guys. We're supposed to solve this question together. And nobody's contributing. Okay, if you can't see it clearly, just try and can you all see it clearly now? Just zoom it out. If you can't see, just zoom it out so that you can see it on your phone. Yes, just zoom it out so that you can see it clearly on your phone. I'm going to send it to you on the WhatsApp chat. So this was how we got the first R1, R8. So the next one. I want to share the diagram again. Oh, so that we would save time. Let me just share the next one. I hope you can all see the next one too. What I really want you to see here is how I now drew the diagram again. I hope you can all see how the diagram changed. Okay. Let us do it this way. I'm going to explain how you are supposed to solve this. And I would want to get the answers by the end of the day. It's 12 o'clock already. So we solved this R8 and R10, R8, R10, R9. We solved it already. Then it becomes a single resistor. A single resistor that is in series and parallel to R7 and R6. Then you get a single resistor too. And you're supposed to do the same thing till you get to R1. You get two resistors till you get to R1 and you get the equivalent resistance. Just try it out, guys. After a few number of you guys have submitted the answer on the WhatsApp platform, I'm going to send you this. So before today's class comes to an end, any question, contribution, what you don't understand, what you would want me to hammer more on? Guys, any question, contribution? No question? Guys, no question. Okay, in the absence of any question, today's class is going to come to an end. I hope you all understand. So let us meet in our next class. We're still doing electricity. We're still going to be treating more of resistors. Though we might not be doing more of resistance diagram though. But we're still doing electricity, guys. All right, take care of yourselves. Bye-bye. Have a wonderful weekend. Bye.